Hi, plus 2 day Friday. Today we are going to deep dive into the magic Maxwell made with electrodynamics. Actually, we wanted to explore slightly deep into the history. Um, it goes back to 17th century till Newton or even Galileo. So Newton got the supremacy or dominance in the field of science in the 17th century, second half of 17th century, strictly speaking. And at the same time, as we discussed here earlier, Huygens, Christian Huygens, he proposed the wave theory of light. But in some way or other, even Huygens was able to successfully explain the then um, established phenomena, all the phenomena then established related with light. He was not received much appreciation due to the dominance Newton had in the area of math and science. Or that time itself, Newton was known to be professor of natural philosophy. Then there was no physics at all. So Newton was known to be the professor of natural philosophy, uh, and he was having dominance in the area of not only in the area of uh, math or science or physics or whatever be called to be the natural philosophy. He was having dominance in politics as well. So Huygens was sidelined that time. He didn't receive much appreciation for his theory, even though it was really successful in explaining all the then um, identified phenomena like rectilinear propagation of light, reflection, refraction, and everything he was able to explain in a successful manner, but he didn't receive much appreciation. And after around 125 or 130 years after the proposal of wave theory, an experiment, which is a path breaking experiment known as Young's double slit experiment, conducted by a famous physicist, Thomas Young. And the results obtained from the experiment by Thomas Young was not able to be explained using the corpuscular theory proposed by Newton. So at that moment, again, Huygens' theory came onto stage and successfully explained that particular phenomena. That was what happened that time. Then the theory, which remained dormant for around 1.5 centuries, came onto the front stage, and that got appreciation, and because it was able to explain all the phenomena uh, explained by Newton, plus it was successful in explaining the phenomena which is Young's double slit experiment, which was actually an interference experiment. And later, several phenomena like diffraction and polarization, such phenomena related to light were discovered, and all those phenomena were explained by Huygens wave theory in a elegant manner, in an elegant manner. Then almost it was established that light is a wave, and one gap existed at that time was people was surprised to see light coming from distant stars, sun, and reaching our earth. And during this particular journey, light is crossing through vacuum or free space in between the light producing celestial objects and the earth. So the natural doubt was how it is possible to for light to pass through vacuum being a wave, because a wave is supposed to propagate through a medium, a mechanical medium. So that was a doubt, and Huygens uh, given an explanation that there is a medium which is uh, filled the entire, which is filling the entire universe. Okay, and he named that medium to be ether. So several experiments were conducted in order to identify the existence of ether. And one such massive or path-breaking experiment was conducted by Michelson and Morley. And in this session itself, we had discussed about Michelson-Morley experiment in one of our previous live sessions. You can watch the recording to get more idea about it. Okay. Now with the results from Michelson-Morley, it was really established that ether is not existing. And around that time, or even before that, in the year around 1860s, Maxwell identified Maxwell tried to learn more about the area of electricity and magnetism. And strictly speaking, the contribution from Maxwell is, or we will identify the contribution of Maxwell is so small, but the entire framework or the entire umbrella of electrodynamics was attributed to, or Maxwell is considered to be a legend in the area of electricity and magnetism. We wanted to look into that. Okay, let me share the screen with you for better clarity. See the four equations which are known to be Maxwell's equations. Actually, even though we are saying that these four are Maxwell's equations, actually the only contribution by Maxwell is this term only, epsilon 0 into d phi e by dt, which is called as the displacement current, or simply we can write it as ID. So this is ID, displacement current. Actually, the first equation, it is the Gauss theorem in electricity. Second equation, it is the Gauss theorem in magnetism. Third equation, it is the Faraday's law of electromagnetic induction. And the fourth equation, it is nothing but Ampere's circuital law, or Ampere's circuital theorem. And considering all the four equations, Maxwell found an inconsistency related to Ampere's circuital theorem. Actually, this was the part, line integral of B dot dl. Or if we integrate magnetic field over a closed loop, that will be equal to mu0 times the net current enclosed by that loop. It is the statement by Ampere's circuital theorem. And Maxwell observed an inconsistency related to this particular theory proposed by Ampere. And it was observed in between the plates of a parallel plate capacitor during the charging happens. So whenever a capacitor is getting charged, if you place a compass needle in between the plates of parallel plate capacitor, it will show a deflection, which indicates that the presence of a magnetic field. Presence of a magnetic field. But if you apply Ampere's circuital theorem to that particular region, you will get that the current is zero there, because there is literally no connection between the two plates of a parallel plate capacitor. So we can argue that there is no current acting or flowing in between the two plates, or within the capacitor, there is no current is flowing. So without the flow of a current through a conductor, we are obtaining a magnetic field. We are experiencing the presence of a magnetic field. We can observe the deflection of a compass needle in between the plates of a parallel plate capacitor whenever the capacitor is getting charged. So the physical experiment reveals that there exists a magnetic field. If you try to explain that existence of a magnetic field at that region using the established law of Ampere's circuital law or Ampere's circuital theorem, it fails, or it gives a negative result, that there is no current existing at that point, or there is no magnetic field existing at that particular point. But in reality, experimentally, we can observe that there exists a magnetic field. Then there is a contradiction happens between reality and theoretical explanation. And here Maxwell explained this by introducing a beautiful term which is called displacement current. And it is existing only when a changing electric field appears. And whenever a capacitor is getting charged from 0 to its maximum value, the only parameter, only physical quantity, only vector field which changes at that particular region is nothing but electric field. So Maxwell concluded that it will be this changing electric field which results in producing a magnetic field in between the plates of a parallel plate capacitor when it is getting charged. So Maxwell explained that, and he was able to calculate the magnitude of displacement current to be epsilon 0 times d phi e by dt. So if we consider the total current I to be the sum of conduction current plus displacement current, then the equation by Ampere, it can be written as closed line integral of B dot dl equals mu 0 times I. And what is I here? I is nothing but the sum of IC plus ID. So if you're considering a situation where a current carrying conductor alone is involved, then there will be no relevance for the second term, that is displacement current. But if you're considering a situation where a space in which electric field is continuously changing, as in the case of a capacitor getting charged, then there is no point in thinking about the first part, that is conduction current. There is only displacement current. And there will be situations in which both conduction current and displacement current are relevant. And by introducing this particular term, displacement current, Maxwell was able to successfully fix the inconsistency happened to the Ampere's circuital theorem. So literally speaking, only the introduction of this particular current, that is displacement current, was the contribution by Maxwell into the area of electrodynamics. But that introduction of a small concept called displacement current into this network or this framework changed the entire scenario. And by analyzing these equations, Maxwell was able to find a unique calculation, which out of which he found that the existence of a special type of waves, which are called electromagnetic waves, which are propagating as a result of the oscillations by mutually perpendicular electric and magnetic fields. And he was able to calculate the speed of such a wave, which is called electromagnetic wave. And as per his calculation, precise calculation, it clearly revealed that uh, it is closely related to the electric and magnetic fields. That means he got the value of C to be 1 by root of epsilon 0 into mu 0. Here epsilon 0 is the electric permittivity of free space and mu 0 is the magnetic permeability of free space. And in free space, the velocity of light is found to be equal to 3 into 10 raised to 8 meter per second. And this value he got accidentally by doing the calculation with these set of equations. Gauss theorem in electrostatics, Gauss theorem in magnetism, Faraday's law of electromagnetic induction, plus Ampere's circuital theorem modified by Maxwell. All these equations, these set of 4 equations, is able to explain each and every phenomena which we are learning under the umbrella electrodynamics. That means electricity, magnetism, and AC alternating currents and EM waves. Entire umbrella is covered, can be covered using only these 4 equations. Simply. So that is the beautiful way in which Maxwell explained Maxwell unified the area of magnetism and electricity. And it was a path-breaking achievement by Maxwell. So, when we are considering the chapter electromagnetic waves in +2, most of the students and teachers, they ignore this particular chapter. Why they are ignoring? There is no much weightage for that particular chapter. Even you are considering the board examination or in the case of entrance examination, the weightage given to that particular chapter is very, very less. And due to the same reason, teachers never pay much attention to that particular chapter. Students also follow the same song. And actually, students are missing the opportunity to understand the beauty of unification of electricity and magnetism by Maxwell. It was choreographed in such a beautiful manner. I will not be able to give you the clarity of the beauty or the aesthetic dimensions related to that particular analysis in a short session, 20 or 25 minutes long. It should be a continuous journey. If you are diligently following the branches of electricity, magnetism, electromagnetic induction, alternating currents, then if you are coming to the area of EM waves, you will be able to understand the beauty. If the foundation stones are placed appropriately. So the foundation for this is coming from +1 topics as well. Because in order to understand electricity and magnetism, starting from electrostatics, then current electricity, then magnetism. Magnetism is also a similar area. Okay. Then coming electromagnetic induction, then alternating currents, then coming to the area of EM waves. So in order to follow the sequence, or in order to internalize the beauty of this particular sequence, you should be having a thorough foundation related to +1 topics, starting from the very basic fundamentals. And it is just like building a construction or building a house or apartment or a tower. Every foundational stones should be placed or should be put in place. Then only the building will be having strength. It will pass the test of time. So I would like each one of you to explore the beauty, but strictly I will admit that it is not an easy process. If you are having strong insights with each and every foundational stones in place, then you will be able to follow the follow the actual flow of the content, and you will be mind blown. You will get mind blown with the various insights, and definitely it will help you in your future journey, whether it is learning journey or your career journey. You will enjoy the life literally. So my request is to identify the gaps and cracks which are existing in the current education system, and we people are supposed to break the chain. If you are able to crack the situation, crack the code for the next generations to come, definitely this planet will be a better place for the next generations to come. So I'm on a mission to help 1 million students explore physics by understanding the real beauty, enjoyment, fun, and enthusiasm related to the joy of learning physics. And without experiencing the pain of internalizing physics, especially this is happening when a student is moving from class 10 to class 11. Such a drastic transformation or transition happening when the student is moving from 10th to 11th. So all these things I will be discussing in my 2-hour webinar, which is called as Physics Made Easy. So if you are willing to spend 2 hours with me, it's a free webinar, Physics Made Easy. And my strong recommendation to you, if you are a student, attend the webinar along with your parent. If you are a parent, attend the webinar along with your student. Whether your child is studying in class 7, 8, 9, or 10th, the webinar will definitely be useful for them. Okay. Even for +1, +2 students, they will be able to get some valuable insights to identify their stature, current stature. I will put some mirror in front of you, which will help you to identify your core strength, weakness, which all foundational stones are misplaced in the case of your learning. Everything you will be able to understand. Okay. So my request is to register for my free webinar, which is called Physics Made Easy, which will help you to get valuable insights. The description for registering the free webinar is given in the description. You can make use of that. So signing off. Thank you very much. Bye-bye.